everybody. In this video, we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku 6th edition. This is practice problem number 6.5, and in this we are asked to find out the energy stored in the capacitors under DC conditions. So this is important. Under DC conditions, what's the energy stored in the capacitors? So we are having two capacitors. This is capacitor number 1 and this is capacitor number 2, and we need to find out the energy stored. So under DC conditions, another thing is the capacitor will be open. Okay, so if you apply simply this 50 volt supply, that is the DC, isn't it? So under that condition, this capacitors will be open. So if you want to find out the energy stored, the formula should be known to you. It is nothing but the energy stored. So the energy stored is W, that is equal to half into CV square. So we must know the value of capacitors as well as the voltage across it. Okay, voltage developed across it. So if you consider this as C1 and this as C2, here you can make it as C1 V1 square, the voltage across it. So this voltage across this one will be equal to the voltage developed across this particular resistor. That is important. Okay. Similarly, when you want to find out the voltage across this, we can make it as V2. That V2, here you should know it is developed across the capacitors, right? So for C1, what it is, these two ends are there. So across this resistor is connected. So whatever be the voltage developed across this will be the voltage developed or voltage developed across the capacitor too. Okay, voltage at the capacitor, right? So if you look at the C2, so this is C2, right, with the two terminals here. So for that, we need to find out the voltage developed across this 3 kilo ohm as well as 6 kilo. Because if you start from here, it comes like this, isn't it? So this is the voltage which is being developed across these 3 kilo ohm as well as the 6 kilo ohm. So that is the case. Now we can easily find it out. So now first it is W1, that is the voltage developed. So for that we need to first find out the current which is flowing through this. Let's take it as I current. Right? So that is equal to I current is equal to the total voltage. I is equal to V by R, the Ohm's law. So V by R is the summation of all these resistances because they are connected in series. So it is 1 plus 3 plus 6 kilo ohm. That means it is 10 power 3. This is equal to 50 divided by 10 into 10 power 3. So it is 5 milliamps. So 5 milliamps current is flowing in this circuit. That means the same current is flowing through this 3 kilo ohm resistor also. That means the voltage developed, this V1 is equal to V equal to IR, isn't it? So that current is, that resistance value is 3 into 10 power 3 and the current is 5 milliamps, 10 power minus 3. So it is 15 volts. So once you found out this voltage, then you can go for calculating this energy stored. So what's the capacitance value there? It is 30 microfarad, isn't it? So it is half into that 30 microfarad. So 30 into 10 power minus 6 multiplied by this V1 square. V1 square is 15 square. So this is equal to 3,375 into 10 power minus 6. So this can be written as 3.375 millijoules. So this is the W1 or the energy stored across this 30 microfarad capacitor. So we got the first answer. Now we can move on to the second one. So what is the voltage developed across this second capacitor? Second capacitor is here nothing but that 20 microfarad, isn't it? So we need to find out the energy stored in this 20 microfarad capacitor. So for that we need to find out the, similarly we need to find out the voltage developed across this also. Okay, so let me take it as V2. So this is equal to half into that C. I have taken it as C2. Instead of V2, we can take it as, it is the summation of this V1 plus V2. The energy stored in this 20 microfarad capacitor is equal to half into that C2, that means it is 20 microfarad, multiplied by the voltage drop across it, means it is V1 and V2, summation of both squares. Okay, so we can calculate this V2. How do you calculate V2? V2 is nothing but that 6 kilo ohm resistance, this one, multiplied by that current I. I value is nothing but 10, 5 into 10 power minus 3. So you got it as 30 volts. Okay. So this thing can be substituted and this work done. So that is equal to half into C2 values 20 microfarad. So 20 into 10 power minus 6. V1 value already we found it as 15 plus this one is 30. V2 is 30 volts per. So it is 10 into 10 power minus 6, then 45 square. So this is equal to 20,250 multiplied by 10 power minus 6. So this work done or the energy stored in 20 microfarad, that is equal to 20.25 millijoules. So this is our second answer. So the first answer we got it as W1 is equal to 3.37 millijoules. Then also we should put the unit, right? Okay, thank you. Hope you have understood.